You wait your entire life to get older. You can't wait till you turn. Just can't wait till you turn 18. Or, I don't know, you wait. You can't wait to be a teenager. Then you can't wait to turn 18. And then you can't wait to turn 21. Then sitting here and you're 57, about to turn 58. And you can't wish I was going to turn 13. Then again, I would not want to live in the world. I'm not a chance. Okay. So you will have to do one like this. You'll have to do one with decimals, and you'll have to do one with fractions. That's a bonus. Step by step, simplify both sides completely. Before you do anything else, you simplify both sides completely. That means get rid of parentheses. That's the first step. Inside, there's nothing you can do. Can't combine these at all. So the only way to get rid of the parentheses is to distribute. Do not subtract. You can't go 10 minus 3 because you have to multiply before you can subtract. When you distribute that 3, distribute the negative with it. Bring it down to 10. Negative 3 times 4x is negative 12x. Negative 3 times that negative 5 is a positive 15. On this side. And then keep working from left to right. Keep working the problem from left to right. 3x. 4 times positive 4 times positive 3x. That's a positive 12x. Positive 4 times the negative 8. Don't put plus and negative. Just go positive 4 times negative 8 is going to be a negative. 4 times 8, that's 32. Just work the problem from left to right. If you have to, say it out loud to yourself. Not out loud, but mumble it. Hear the voice in your head as you take care of those signs. If you don't trust yourself with the multiplication, then as you're working that distribution, show that little rainbow. And then as you're doing this, okay, before I write this down, 4 times 8, then either on the side or on the calculator, whatever you have to do to get that multiplication right, do it. Because they're not always going to be nice, especially when you do the one with the decimals. But every step right there was one tiny little problem. Just one small problem. It was, I multiplied negative 3 times 4. Then I multiplied negative 3 times negative 5. It was one thing at a time. Not one huge problem, just one small problem. Now we're going to combine like terms. I'm not trying to solve anything yet. I'm just going to combine what I can combine here. Simplify completely. Focus on the variable. You should write the variable stuff first. This is a negative 12x. So I'm going to check this off, negative 12x. And then I have a positive 10 and a positive 15. That's positive 25. That's what I have on the left side. There's an equals between the left and the right. Separates. The left side is simplified. On the right side, the variable terms are these two. They both have x's. 3x and 12x add up to 15x. Get them wrong. And then I have a minus 32. So on my left-hand side, I got the negative 12x plus a 25. On the right side, it's equal to a 15x minus a 32. That's all step one. Simplify both sides completely. Then, now you focus on the variable again. Get the variable on one side. Pick the side you want to get the variable on. Either going to pick the left or pick the right. So think it through before you do it. If I bring the variables to the left side, that means the 15x has got to bring over to the left. To undo positive 15x, you would subtract 15x from both sides. Subtract 15x. That means I have a negative 12 and a negative. I'm going to have a negative amount of x's. or I can take the x's to the right side. So I'm going to add 12x to both sides. So either way, once you kind of think it through before you make the move, now you decide. Do I want to bring it to the left and have negative x's, or take it to the right and have positive x's? Which way? To the right. So I'm going to add 12x. And then, again, focusing just on the variable, I have 25 left over on the left side. And that equals 15x plus 12x, that's 27x. And don't forget, a negative 32, minus 32. Since we decided to take the variables over to the right side, that means we got to bring the constant over to the left, separate the variables and the constant. So now to undo negative 32, we add 32. 25 plus 32 is 67. Or 50, 57. I was thinking of my football number, which was always a clean jersey because I never got it. Ask about why's your jersey always so clean? Because you never put me in, coach. Oh yeah. Next time, just slide around on the side of it. It'll get dirty. Okay. That way, we take it home over the weekend. Your parents think I actually like you, since they don't come to see your games anyway. Thanks, coach. I turn mine. I'll be over here in the field position trying to inform you. All right. Now, once you've got all that done, it's undo multiplication and or division. 27 times x. Now we divide both sides by 27. Simplify the lowest terms. If it's a fraction, we got to find a common factor. If there is a common factor, 3 goes into both of these. This is 3 times 19. This is 3 times 9. So 19 over 9 is equal to x. Always reduce the lowest terms. Remember, your quiz is open note. So here's another open note for you to use. Okay. Now the bonus questions. First thing about this bonus question is just like the first thing about the one with the fractions that we did on Monday. Undo fractions. Multiply every term by the least common denominator. Well, if you take, it's like a little inventory check. I have a x minus 5 in the denominator, so I need to multiply by an x minus 5 as part of my least common denominator so I can undo that denominator. This denominator is an x plus 5, so I'm going to have to multiply everything by an x minus 5 and an x plus 5 in order to undo both of these. Now, here's what I'm hoping. That x plus 5 and x minus 5 will undo this. If you are struggling or don't know how to factor, this is what Monday's co-rec is going to be about. We will be factoring. And that's why I'm doing these right here. Before we make sure we can factor, we got to make sure we can multiply. When we factor something, let's just look at 24. You want to figure out, give me two numbers that multiply together and give you 24. Any two numbers. 6 times 4. And then can you break 6 up anymore? 2 times, and 4 is 2 times 2. So this is 2 times 2 times 2 times a 3, which means you could write it as 2 to the third times a 3. This is the prime factorization for 24. When you factor something, you want to take that number and write it as a multiplication problem. Right now, this is a difference subtraction. I want to rewrite this as multiplication if I'm going to factor it. Some of you know how to factor because you had lazy algebra teachers. And they taught you things like bottoms up or the diamond method or some crap like that. Because it is crap. It's just lazy. I try to help you guys learn how to think. Because it's a puzzle you're unraveling. It's like, give me two numbers that make 24. Because you could have picked 3 times 8. There's a 3. That's 2 times a 4. There's a 3. There's a 2. Hey, we get 2 times 2. There's 2 to the third times 3. Or we could have picked 2 times 12. There's a 2. There's a 3. There's a 4. There's a 2. There's a 3. There's 2 times 2. 2 to the third times 3. There's more than one way to get there, but if you only have this one method of doing it, you're really limiting yourself in terms of thinking. So I always try to teach how to get there by thinking. It's just trying to reverse, again, like distribution, we reverse it by dividing. First times first is x squared. Well, the only way you're going to get an x squared is x times x. First times first is x squared. And then we take it apart again. Last times last is a negative number. The only way to multiply and get a negative is if you have a positive times a negative. A positive times a negative will make a negative right here. Last times last has to make a 25. Well, there are 2 ways to make 25. You could do 1 times a 25, 1 and a 25. But the problem is I want 0 in the middle. If you FOIL this out, x times x, there's my x squared. X times negative 25 is minus 25x. 1 times x plus x. 1 times negative 25 is negative 25. If I multiply this out, I get x squared minus 24x and a minus 25. I have the x squared, I have the negative 25, but I have this in the middle. I don't have that in the middle. So this isn't the answer. So there's another way to make 25. Because 1 and 25 is an x. My method is more scientific. It's called guessing and checking. Okay. We tried 5 and 5. I guessed the 1 and 25. So now I'm gonna, and I checked it, didn't work. So now I'm gonna guess the 5 and 5. X times x, go x squared. Positive x times negative 5 is negative 5x. Positive 5 times x is positive 5x. Positive 5 times negative 5 is negative 25. There's the x squared. Negative 5x plus 5x cancels out. That's 0, x is in the middle, and minus 25. Those add up to 0 in the middle. So that's the factorization. Now, when I say guessing and checking, what it needs to be is educated guessing and checking. And then when you do enough of these, you start to see patterns. And so it's no longer really guessing and checking. I've seen something like this before. When it looks like this, I know what it's going to be. And you're no longer just plugging it into some kind of diamond method, bottoms up, whatever. And you're letting something else do the thinking for you. Because when we do trig, we're going to have to do something like 3 sine squared theta minus, let's go 4 sine theta, cosine theta, and then plus cosine squared theta. And you got to factor, you factor x's. And you factor it the same way. But instead of x's, it's sine squared and cosine squared. So this is actually, I'm going to rewrite it up here. It's 5 over x minus 5 minus a 1 over an x plus 5 equals 2 over x squared minus 25, which we just showed is actually x plus 5 times x minus 5. And the whole point of that was, number one, show some factoring. But number two, we want to undo the fractions, which means we need the least common denominator that's going to undo all the denominators. To undo this denominator, we're going to have to multiply by something with an x minus 5 in it. To undo this fraction, we're going to have to multiply by something with an x plus 5 in it. And to undo this fraction, it's going to have both an x plus 5 and an x minus 5. And there it is. That's the least common denominator. And that's how your quiz question is going to be set up. Whatever's going to undo these over here will actually undo the one that is not factored for you. So when you see your quiz question, these two factors over here, make sure you rewrite the right side with those factors, because that's what's going to be necessary. So everything gets multiplied. Everything gets multiplied by this. Don't be lazy. Each one has to have this times those factors. So this one has to get multiplied by x minus 5 times an x plus 5. Then this one has to get multiplied by an x minus 5 times an x plus 5. And then this one needs to get its own x minus 5 times an x plus 5. What I'm seeing is like just a one-time writing this and then trying to figure out what's left over. If you don't see that common denominator or that least common denominator right next to each one, you don't see what's left over. Because now you see what reduced is right in front of you. Right here, only the x minus 5 reduces, and you're left with this 5 times that x plus 5. Now we have minus. The x plus 5 reduces. Now here's where we got to be careful because of the minus. Minus that parentheses x minus 5. And I'm keeping it in parentheses because when you subtract more than one term, you're going to have to distribute the negative. So all I'm doing right now is simplifying the denominators. I'm not doing the subtraction yet. I'm not doing the distribution here with the 5 yet. I'm just cleaning up the mess with the fraction. One step at a time. And over here, what's left on that side? Just the 2. The x plus 5 reduces, the x minus 5 reduces. So this is 2 over 1 times 1. No more fractions. 5 times x. 5 times 5 is 25. Minus x. Minus negative 5 is now plus 5. Equal to. Finish simplifying. This is all still step 1. 5x minus x, that's 4x. 25 plus 5, that's plus 30, equals 2. So look at the question that we now are trying to work with. That's just step 1 finally done. Once we've simplified both sides completely, look at the problem it is. Factor. We get 4x is equal to negative 28. Divide by 4. And x is equal to negative 7. And it just took the patience to get through and do step 1. Step one is what it takes. Simplify the fractions, undo the fractions, and then clean up both sides. It's not that bad. At least these aren't. Again, that's a bonus question. A few of these. We've done quite a few of the multiplications already with the special properties. So I'm going to multiply these out. You tell me out of 3 through 8 what you need to see. Number 3, the answer is, put them on this side. This one is x squared plus 8x plus 16. This one is x squared minus 16x plus 64. This one is 9x squared minus 30xy plus 25y squared. This one is x to the 4th plus 18x squared plus 81. And this one's going to be 16x squared minus 9. This one, well, this one's going to take a little, because it's not one of the special. This is 18x squared. And we're going to get a negative 33x. And then minus 40. On 3, 4, 5, and 6. The special products that I used were, if you have A plus B perfect square, you square the first one, and then the middle is you multiply the first and last term, A and B, but you double it in the middle, 2 times AB, and then you square the B plus B squared. So, for instance, x squared, multiply x and 4, so you get 4x, but then you double it in the middle. So 2 times the 4x is 8x. And then you square the 4, 16. If you have subtraction, a minus b squared, it is exactly the same terms, except the middle is a minus. It's still going to be an a squared. It's still going to be a 2ab, but it's going to be a minus 2ab. That's the only change. And it's still going to be a plus b squared. Because when you do last times last, when you have that x minus 8 times the x minus 8, your last times last is a negative times a negative. So the last term is always going to be a positive. So you square the first one, x squared. You multiply the first and the last term, these two. X times 8 is 8x. And then you double it, it's minus 16x. And then plus a squared. That's this one right here. 3x minus 5y squared. I squared the first one, 3x, I got it squared. And then minus 2 times, I multiplied these together. I multiplied the 3x and the 5y. And then it's plus the 5y has to get squared. 3x squared is 9x squared. Multiply the 3x and the 5y, that's 15xy. And then you double it. 2 times 15, that's minus 30xy in the middle. And then you square the last term, it's going to be addition, 25y squared. That's if you want to use a special product. Otherwise, you write it out. 3x minus 5y. 3x minus 5y, you distribute, keep track of your terms. Keep track of your sign.
So when it's a minus something, when you split them up into two parentheses, it's two negatives.
Yeah, because you're multiplying it times exactly itself. So it has to be exactly the same thing. This times itself. And that's why we get a negative times a negative, and that last one's called positive. And in the middle, we would have a negative 15xy. When we do this and we do this, it's another negative 15xy. And that's why we have two of those negative 15xy's. That's like negative 30 in there. This one right here, we just got done factoring. This one is a plus b, a minus b. The terms are exactly the same. You have an a, you have an a. First terms are exactly the same. The last term is a b and a b. The only thing that's different is one is addition, one is subtraction. So exactly the same first term, last term. The signs are different. When you multiply together, it's called the difference of two perfect squares. The a is squared, and it's going to be positive times a negative. The last term is going to be a negative, and the b is squared. The middle is a 0, and that's what the second example was like. The second example gave me 0. Because it canceled out in the middle when we factor that x plus 5, x minus 5, x squared minus 25. Right here, 16x squared plus 12x, and then a minus 12x, so it's going to make a 0 in the middle, and then a minus 9. A squared, 4x is going to get squared, and then a minus 3 squared. Now, the negative is not being squared. It's going to be a minus in between. So 16x squared and a minus 9. That definitely needs to, you definitely need to know how to use that one. Not so much because of multiplying it out, but it's going to be one of our quickest valuing problems when you recognize that as factor. Major things we better make sure we can do is when we get to these radicals, these square roots. What is 12x plus 3x? 15x. So square root 9 plus square root 4, square root 2 plus square root 2, 5 square root 3 plus 4 square root 3. So it's square root 9 plus square root 4. Ah, good. Okay. And that's because you always simplify the radical before you do anything else. You always want to simplify everything you can before you do addition. Remember, the last thing you do in order of operations is addition, subtraction. Order of operations, add, subtract is the last thing. So I want to simplify these radicals if I can, and then I'll add or subtract. The square root of 9 is 3. The square root of 4 is 2. 3 plus 2. That's no problem. What is the square root of 2 plus the square root of 2? No decimals. We want the exact value, so we're not going to go decimals. No. I think I got a couple of 2. 2. Okay. But you said 2.8 approximately. 2.81, 2.28. Little closer approximation, so it can't be both. So real quick. When we added these up here, square root 9 plus square root 4, did we get the square root of 13? Did we? Because is the square root of 13 the same as the 5? I mean, do you agree the square root of 9 is 3, square root of 4 is 2, and 3 plus 2 is 5? So this is definitely equal to 5. Everybody okay with that? Then this is impossible to get us a 2. That is not true. Which means with square roots, you don't just add the inside, you don't add the insides. The square root of 2 is an irrational number. It is approximately 1.414. So 1.414 plus, again, decimals we don't want, 1.414 is not going to add up to a 2. You treat it, and that's why I give you this question. 12x's plus 3x's is 15x's. 1 square root 2 plus another square root 2 is 2 square root 2's. You treat it like variables. One of them plus one of them add up to 2 of them. It's about how many of those square root 2's do we have. You don't add up the insides. Okay? You don't add up the insides. So here, 5 square root 3 plus 4 more square root 3's is how many square root 3's? We have 9 square root 3's. 5 of them plus 4 of them is 9 of those square root 3's. This right here is 5 times the square root of 3 plus 4 times the square root of 3. It's like saying, what's 5x plus 4x? It is exactly like saying this. You treat the square root of 3 just like it's a variable. When you add, subtract, multiply, divide, you combine like terms, you combine like radicals. So if you had, what's the square root of 2 plus the square root of 3? That's lowest. You can't simplify that any further. They're not like terms. It's like trying to add x and a y. It does not equal square root 5. Okay? Just like right here, we did not get a square root 13. So I can't add these together and get a square root of 5. So what's the final answer? Just right here, square root 2 plus square root 3. Okay. When we want exact value, you leave it as a square root. It doesn't simplify any further. I have 1 square root 2 and I have 1 square root 3. I have 3 green pens, 2 red pens, and I can't combine them together and make one kind of pen. They're not the same kind of pen. I have 2 square root 2, 1 square root 2, and 1 square root 3, and that's, I can't make 1 square root of that at all. I can't put them all into 1 square root. They're not the same kind of thing. Okay? That's part of 2.3. All right, let's get back to 10.